how much of our digital exhaust or this stuff has been used to like manipulate people's behaviors and their sentiments about things. I think, a big part of the argument of who controls TikTok is based on like who gets to censor which data and why. And that should be concerning to anyone, because again, it's not that in good times that we have these powers. It's in bad times, the people who might abuse them are the ones that we should worry about.
Hey there, you're listening to Book Overflow. This is the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toups. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, thanks for listening, everyone. Make sure to like, comment, subscribe wherever you're at. Leave a 5-star review. Share the podcast with your friends and coworkers. It's been fun. You can join the Discord, and in the Discord, we have an Introduce Yourself channel. And I always like hearing how people discover the podcast. And we've heard several people who said, oh, yeah, I was talking to a buddy about it, and they recommended it. So it really does help the podcast grow. And if you're interested in booking time with Nathan or I on Leland for one-on-one coaching about your career or just any sort of software topic, you're more than welcome to do that. Links are all in the comments. As far as what we've got going this week, we've got our finale. That's probably too grandiose a word. For designing data-intensive applications, this has been our first and only 4-parter. It's been intense. We're going to do the author introduction, the book introduction, talk about what we thought of this last section of the book. But I think we should take a moment up top, Nathan, to appreciate we did it. We did it. Designing data-intensive applications.
We made it all the way through, and I'm excited to talk about it today.
Yep, it's was by far the most requested book of the podcast, and so we can say that we have fulfilled your wishes. And we're ending the podcast now. That was the only purpose, was to work ourselves up to designing data-intensive applications. And this is going to become this is a ClaudeBot podcast now. So every week we're just going to talk about Moltbot and Moltbook.
Yeah, you basically we're taking that LinkedIn strategy. We're just going to get real unhinged and be like, everything you know is wrong. Here's my 15 bullet point emoji list of everything I've learned in the last 3 weeks using Moltbot.
It's Twitter is just like this constant back and forth of like, AI will never replace software engineers. Like, and it's so over. And I hate that phrase, like, this is your last chance to escape the permanent underclass. I'm just like, I promise you, whatever comes, that's not true. Anyhow, we'll probably talk about some of that over the course of the episode. Who knows? But let's do this book justice. Let's talk about Designing Data-Intensive Applications by Martin Kleppman. Give the author introduction and the book introduction. For the author, we have Martin Kleppman is an associate professor at the University of Cambridge, where he works in distributed systems and local first collaboration software. Before academia, he was in the trenches. He co-founded Rapportive, which was acquired by LinkedIn in 2012, where he worked on large-scale data infrastructure. He's also one of the few people behind, not one of the few. He's also one of the people behind AutoMerge, an open source library for building collaborative applications. And for the book introduction, we have data is at the center of many challenges in system design today. Difficult issues need to be figured out, such as scalability, consistency, reliability, efficiency, and maintainability. In addition, we have an overwhelming variety of tools, including relational databases, NoSQL data stores, stream or batch processors, and message brokers. What are the right choices for your application? How do you make sense of all these buzzwords? In this practical and comprehensive guide, author Martin Kleppman helps you navigate this diverse landscape by examining the pros and cons of various technologies for processing and storing data. Software keeps changing, but the fundamental principles remain the same. With this book, software engineers and architects will learn how to apply those ideas in practice and how to make full use of data in modern applications. So this is the final week. We read chapters, is it 12 and 13 or 11 and 12? I forget.
11 and 12, yeah.
11 and 12, the final 2 chapters. Let me get the titles of those for you.
Yeah, so chapter 11 is stream processing. Remember, last week we left off on batch processing, which was the beginning of part 3. Stream processing. And then 12, I loved it. 12 is sort of, I think it's called The Future of Data Systems. And he gets to round up everything we talked about, pontificate about the future. And then also he had a really great section on data privacy and
Yes.
Some other stuff that in surveillance that I think is really worth talking about.
And of course, by the future of data systems, we mean the future as Martin Kleppman saw it in 2016. But I think there is still a lot here that applies. But I really enjoyed the last section too. I guess, yeah, Nathan, give me your overall thoughts. I know you just shared some, but if there's anything else you'd like to
Yeah.
share.
So I thought this book ended on a high note. I think it finishes off nice and clean. We took everything that we learned and sort of it gets us to this sort of thesis around streams and how streams are this sort of logical next step after batch processing. It brings up a lot of the interesting distributed database and data system problems that we kind of visited over the course of the book. And I actually think, even though this was and then of course ends it out on a glimpse into the future from 2017 or 2016. And I think that his views on things have not changed. There's really some, I shouldn't say his views haven't changed. His views on the future are still very applicable now, almost 10 years later. And actually, with the rise of AI and agentic AI, I think the data privacy and surveillance section is probably more important than ever to think about. And I don't know, I'm excited to dig in and talk about the rest of it. What about you?
Yeah, I'm glad. I'm glad we read it. We did it. I think I found this book to be. I've been upfront about this. That this book, I just remember preparing for big tech interviews, and I was like, I should buy and read this book because this is like the book everyone talks about, right? And then I ultimately didn't do it because I think, like most people, I probably got a chapter in and then quit reading. And that's why we have this podcast, because it forces us to keep reading some of these longer books. But it's not incredibly applicable to your like day-to-day job. This is much more like, I guess if your day-to-day job was like literally, designing and building Kafka, then this would be helpful for you. So this isn't so much an implementation guide as much as like discussing the underlying theory, which is really, really interesting. And I really enjoyed it because we are exploring more and more of an event-driven model at work for some of the parts of our system. And this book is all about event-driven stuff. This last chapter, stream processing, talks a lot about kind of event-driven architecture and how that all fits in with the streaming model. So I really, really enjoyed it. But it's all at a very, very deep level. And I think you just got to know what you're getting into as you read this book.
I will say, if you're in a career path that's in data engineering, or platform engineering, cloud architecture, sort of these areas, I do think that, typically those of us working in those areas try to abstract this stuff away so that the Carters of the world can just focus on solving business problems, right? So if I'm doing my job well, you really shouldn't have to think about these sort of like weird things all day. Really, hopefully what you're thinking about is, I have this great library. If I use data in this pattern, I can lean on this system that my SRE and platform engineering team helped us build. And I know that this transaction is going to go through with whatever, certainty level that we have in place. And so I think that that's where, like, sufficiently advanced technology is indiscernible from magic, right? The Heinlein quote. And I think that's true for good platforms. good data intensive infrastructure has abstracted away this cognitive load for users day to day. And so I do think that this book, if you're getting into the sort of juicy nitty gritty details, or you want a good, and I've talked about this before, right? With the NP complete stuff, a lot of the graduate algorithms classes to teach you the class of problems you shouldn't try to solve. This book is a great reminder of, hey, these are juicy, hard problems. I probably shouldn't be trying to figure them out unless I'm a PhD researcher. What's the best in class tools that are available that meet the trade-offs that our team needs? And I think this book gives you vocabulary to have those conversations and go, okay, I've heard a lot about Kafka. This organization I'm interviewing with uses it heavily. I see, because of their business model, why, right? This book will give you enough education to not be completely ignorant of those trade-offs.
Understanding those underlying patterns is really important, because like you talk about, no, any sufficiently advanced technology is indistinguishable from magic. We have actually, this is only semi-related, but at work, we have been using GraphQL, and we're exploring a pivot away from GraphQL to REST, because there's a bit with GraphQL where like, oh, it just works. You just write the query and you get back the information you need, and like it's all fantastic. But if you don't know what you're doing with GraphQL, it's really, really easy to write incredibly inefficient, incredibly non-performant GraphQL that just bogs the entire system down and makes everything so slow. And so, you know, I think I say we because I'm a member of the team and I take responsibility. A lot of these decisions were made before I got here. But I think we were just kind of like, yeah, you know, let's use GraphQL and it's going to be great. But not understanding how it operated kind of underneath the hood has really been a troubling point for us. And so, you know, do you need to know everything in this book to hook up an Amazon SNS that hooks into, you know, an SQS queue and just processes some events that flow through there? Probably not. But having an idea of all the different patterns in stream processing and kind of what's going on at a lower level, you know, it's never going to hurt you.
Hey gang, quick announcement. I'm excited to share that I'm relaunching Rojo Roboto, my platform engineering consulting practice. If you need help shipping faster with better infrastructure, DevOps, engineering enablement efforts, let's talk. Book Overflow listeners get 10% off their first engagement. You just go to rojoroboto.com/bookoverflow. That's ROJOROBOTO.com/bookoverflow. Okay, great. Now back to the episode.
And so I guess we can just get right into it with stream processing, because that's what chapter 11 is all about.
Oh man, I'm so excited.
It makes the distinction up top between, because really we talked about batch processing last week, but batch processing, stream processing, and the future of data systems are all in the final section of the book. Batch processing, there's bounded input and it processes a complete data set and it produces output. What's a good like real life example of batch processing? Like everyone always gives like the word count example. I'm trying to think, is there anything more
so any sort of data, like here's a great example of a good batch process. I used to work at a fintech company. We would get a payload, and I'm not joking here, an FTP payload, because the fintech industry is just full of legacy stuff. And again, this is like 6 years ago. Hopefully we've gotten better API development, but we would get NASDAQ data and New York Stock Exchange data and a few other data vendors, and they would deliver these daily payloads at night, 2 in the morning, 3 in the morning. We would have a pipeline that would have to run end to end and have the data available for our internal systems by 8 in the morning. So there was this very like cyclic thing. And so a bounded batch process was perfect for this, right? We didn't need some Kafka stream processor because the data wasn't coming in as a stream. We weren't processing live analytics data or something like this. And batch processing is very easy to reason about, right? We just talked about in the last episode the Unix philosophy. You can really think of this as pipes, where you have this sort of like, you know, immutable input data set, and that's how we treated it, right? We didn't want to modify NASDAQ data that came in, but we would want to do some enrichment and some normalization and all the stuff that you do in a data science team, right? Where we are extracting the stuff that we want, we're loading it into systems, we're doing these other pieces. And batch was really easy to reason about. If something broke, I could look at what step in my batch process that it broke in, right? And do all these things. Of course, data sets have gotten so large and the types of workloads have gotten so large that we now have unbounded inputs, right? For instance,
this stream processing.
Exactly. Right. So, and you can imagine, if we're trying to talk about financial markets, what about financial markets that never rest? What if we have, what if we have a data process that you can imagine we're getting real-time data from the markets as they open and close around the world, right? Now, batch processing doesn't make as much sense. Maybe I could batch process each market as it opened and closed. But maybe I'm doing something in the brave new world, like in crypto. Crypto doesn't have a sleep time for trading desks. You're having 24-hour feeds 24/7. A lot of, I mean, I'm not endorsing it, but things like Polymarket and other trading, sort of other platforms that kind of try to trade all kinds of stuff. You have a continuous set of work that you want to do all the time, and come in. And I guess for internal business processes, this might be an analytics pipeline, right? Imagine you're looking at behavior analytics of ChatGPT's chat interface
Right.
24/7, right? You have tremendous amounts of data coming in. I would imagine that their data science team would like to study behavioral analytics that come out of it. That's an unbounded input, right? There's a never-ending supply of the, millions and millions of active users they're pulling in events from that.
Yeah. There's a lot of different ways you can kind of go about stream processing. I guess the core of stream processing is this idea of an event, right? Which is that an event can be almost anything, right? Like an event is just a record that something has happened. It's an immutable record, right? So whereas like in a database, like a transaction, like for example, let's say let's say you are trying to book, like, I don't know, we do a lot of like one-on-one booking sessions at my work, right? And so you want to book a session one-on-one with someone else, like you're scheduling a lunch, right? You schedule that session, gets entered into the database, and that is a record in the database. But then let's say you want to update the time that lunch is happening. Well, you'd go in and you would modify the time stamp on the event, the happening at timestamp, and then boom, you're done. Events aren't like that. You'll never go back and modify an event and say, actually, I meant for this event to mean these things. Events are just going to be kind of constantly they're going to be constantly emitting. These are, I think, easiest to understand, like what you talked about, Nathan, in the sense of like user analytics, right? Which is like, I click on this, I view this picture, I buy this thing, right? And then all of that stuff gets emitted and kind of consumed by some sort of downstream analysis pipeline. But it can also happen for, like social media notifications, right? Like this is how like all kind of social media, or at least like a lot of social media feeds work like this, right? Where it's like when you log on and want to, you're expecting to have like your timeline filled with 35 tweets, right? Twitter is not going and querying all the tweets that were made in the past 24 hours, right? And saying,
Right.
okay, which ones would be good for you, right? As those tweets are created, they're being emitted as events, and those are being consumed by downstream consumers. And kind of as they come in, there are workers downstream that handle, okay, would this tweet be a good candidate for this user? And if it is a good candidate for that user, it kind of sticks them in your proverbial inbox and then uses those as candidates to populate your feed. So, I mean, that's kind of like a high level overview of event processing and how event processing can work, with the streaming model.
Exactly. And so as soon as we start talking about events, we inevitably start talking about messages, right? And so the idea of messages, and I love the way that they set this up, because especially any of us who've been working through tech for a little bit have kind of experienced some of this. Again, everything's a trade-off. We all have this really strong framework of thinking about the trade-offs in systems at this point. We're in chapter 11, really thinking about stuff. And I love that, he talks about like, well, what type of system do you have? Do you have a voice over IP phone system? Oh, well, that's probably using UDP. And, if you drop some packets, you really just want it to skip or interpolate or try to figure something else out and just move on. There's no point in replaying a part of your conversation from 5 seconds ago. We'll just drop that part of the conversation. When things come back, we're back, right? But he also brings us into things like zero MQ, webhooks. These are what he would call like direct messages. These are messages that kind of go through a system. But as soon as you want to start having sophistication, like guaranteeing that something's handled in your system, this is where you get into systems that you've probably heard of, like RabbitMQ, ActiveMQ, what we would also call message brokers. And these, again, they have some sort of durability guarantee. You might even redeliver. I think when we were talking about earlier, where you're like, oh, just SNS and SQS, right? Which are two AWS services for the uninitiated. But simple queuing service, it can be set up where it just drops messages after a certain time, or you can set it up the much more dignified way using a dead letter queue, right? Or if I failed to deliver or failed to process a message for some reason, I can pull it out in my mail sorter and shove it into a queue that just sits there to be analyzed later, right? There's all these like kind of flow control pieces that you can have. Where I think this is where things get exciting for this chapter, because there's a good nod to these. What I loved, and I think what people love about this, and people have talked about this book, DDIA, really kind of introducing the ideas of Kafka to a lot of people. And these are the ideas that are called log-based message brokers. I would say if there's any excitement in the industry about stream processing and about these things, log-based message brokers are just like a complete shift in your thinking. And it's one of those moments where you're like, when you realize how cool Kafka is and what it represents, you're like, oh man, there's just whole categories of things I couldn't do before because of this. Have you had much experience with log-based message brokers?
I mean, we've used Kafka in previous jobs, but I have never touched it too much. I mean, I guess I hadn't realized that there's a big difference between like a log-based, like a Kafka approach as opposed to like just SQS or something like that.
Oh, it's amazing. I'm gonna get excited about this for a second. Yeah. So, log-based message brokers, and especially there's this whole thing called event sourcing that it kind of has come up out of this. It's not directly related, but highly related. These are append-only logs, meaning that you use this system and it has these like nice partition pieces, and we can talk about those. And again, it's not just Kafka. Amazon has a proprietary service called Amazon Kinesis. I think Twitter has some tech that they wrote a few years ago called like distributed log or something like this. But the idea is you just announce an event on this event stream, right? So you say that something happened. It gets written to this append-only log. And then you have these message consumers that will follow certain topics or certain shards, and they keep track of how much they've processed. So it's this sort of other end of it. But the cool thing is I can come up with a new experiment or a new service idea or these other things and rewind time and go back to, all the way back to, let's say that our Kafka goes 7 days in history or something. I can go back and make a new consumer that starts with 7 days ago and processes all the events in the event log.
Very cool.
Yeah. And so not only can I experiment with new ideas without having to talk to my DevOps team, right? I can also fix bugs. Let's say we realized yesterday our consumer had a bug in it and we've actually processed the data incorrectly.
Right.
I could actually create a new thing that goes back and goes 1 day back in the history, reprocesses these things with whatever fix and amends this data, right? So it's just a super powerful pattern if your data is structured this way, so that you can process data in this sort of like, oh, well, if you have all this certainty around it, I have this append-only log. I know that there's these like strictly ordered set of events per shard, meaning, and there's all these like things around it. He gets into a decent amount of it in the book, that there's like guaranteed message ordering per partition, and partitions can be this whole other thing you can talk about. But for instance, you can do things like let's say you have, 50 partitions. Let's just pick a number. You can do a balancing across these partitions by, let's say, user ID. And so maybe we always need to have any event tied to a user ID in strict order. We always want all user ID events to never go. So what I would do is I would just hash the user ID so that it always gets put in the same partition. It's a consistent partitioning scheme. And so it gets balanced amongst the 50 nodes. And so everything related to that one user maybe sits on some set of the partition table, knowing that anything related to that one user ID will strictly be processed in order of when it saw it. So you get this sort of deterministic replayability that in some systems you need. In some systems, it's really, really important that if I go back and hook up a new consumer and I want to also see what happened in the world, I can rely on this append-only log, right?
Right. So I guess whereas opposed to something like SQS, like once it's processed, it's done. The event functionally no longer exists. Right. That's interesting. Now I got to think about that. I was reading on
Yeah.
Twitter, someone's like, Kafka is either the backbone of your business or meme software for tech interviews, right? Like,
No, no, and it's kind of crazy. Like, there's also some interesting companies that I've seen have used Kafka in some pretty amazing ways. Like, I remember one of the first ones that I really paid attention was there's a not analytics, sorry, observability platform called CoreLogix. We are not sponsored by CoreLogix. I'm just a fanboy. But CoreLogix processes observability data, and they do it much more cost effectively than like Datadog. And if you like the way that CoreLogix does stuff, it's really efficient. Well, one of the reasons that they're able to do this is that everything on their platform is Kafka streams. So
nice.
they're able to have this reproducible hot window of doing observability stuff. And there's a bunch of other secret sauce, but that's their big thing, is that they have this like append-only log of all the stuff that happens and place markers of things, and that you can kind of like rewind and fast forward in time, and do a bunch of really neat stuff. I think another thing that this book brings up really well, and I think actually is probably one of the most important thesis ideas, is what's called CDC, not the Center for Disease Control. This is changed data capture. And this is really cool, right? Like, this is one of those things where you inevitably start thinking about this stuff and you're like, yeah, wouldn't it be cool if anytime I did something on a database, I could like stream that this thing happened in some append-only log, so that other things could like pick up on this stuff happening, right?
Yeah.
Turns out this is like a really cool pattern. You don't have to use Kafka for this. Obviously, there's a bunch of really interesting technologies like I think is it Debezium? I'm going to mispronounce it. Roast us in the comments. But there's a bunch of tools that, and then I think Postgres does this out of the box. There's like a bunch of other things that they kind of outline. But, do I want, every time something happens, do I want to admit that a row was written or some data was mutated or something was there? And if I could just fit that into a append-only log, I can then go back and like react to certain things happening in the database without having to burden the database with a bunch of SQL queries pulling on something, right?
Right. We're exploring this a bit at work. We are exploring a migration of our data from MongoDB to Postgres. The more we look at the shape of our data, the more we realize that it's just kind of fundamentally relational, and Mongo is not a great fit for it, and it's causing all of this. I think a lot of our problems could be solved by just like, if we were Mongo whizzes and understood our system better and understood exactly how to, like, I don't think Mongo is fundamentally the limit here, but I think there is something to be said for like, it's tough to bring on an engineer and you tell them to use Mongo and then say, but also don't use any of these foot guns, right? Like, and that's all our code base is. It's just foot gun after foot gun after foot gun that we're all writing until we realize like, crap, this is how Mongo works. And so we're just naturally thinking in a relational way. So we're like, you know what, maybe it makes sense to do Postgres. I'm like, oh my gosh, a data migration, that's going to be like a giant nightmare just to get that all going. And granted, all migrations are a giant nightmare. But I was pleasantly surprised that we use the hosted version of MongoDB, Mongo Atlas, and that has change data capture support built into it. And it's got a built-in plugin with this AWS tool called, I think, DMS. It's like Data Migration Service. And yeah, it works like in a CDC way. And so I just rigged up, you write like this little mapping file. And yeah, I gave it one of our collections in Mongo, and it formatted all of it. First, it like batch processed the whole thing, right? And yeah, just formats it. It translated it into Postgres, put it all on a new table there. And then as new events come in, whether that's new records being created or records being modified, it replicates to our RDS Postgres table in like half a second. So I was really, really impressed by this. And again, it's just a proof of concept. And I'm sure if we move forward with this and do it in production, we're going to see all the reasons why this is a very bad idea. If you know why it's a bad idea, tell me in the comments. But I thought it was a cool application of CDC.
And this gets to another really cool topic. One that actually came up a lot when I was in that blockchain company. There's this idea of event sourcing. So event sourcing is a neat idea. And the idea is that in an event sourcing system, you have a store of events, which are, again, these are like facts about the things that happened. It's not just the current state. And so the idea is, if you had your event sourcing data all the way back to epoch or whenever you start, doing this thing, if I replay it in order, I should be able to reproduce the current state, right? So that's the very like, it sounds like I'm like talking in circles, but the idea is I can actually take a snapshot and then replay the set of events and reproduce the data in its current state as it's represented in some, source of truth data structure. Well, turns out blockchains are this, right? If I replay the state transitions that are expressed in every block in a chain, all of us can prove that the declared state of the ledger is the way it is. Turns out it's very useful way outside of blockchain stuff. And he talks about this like calculus analogy that I thought was really kind of cool, which is that basically like states are, you integrate events over time, right? It's the state. So like if I take all of these events, I can derive state from this at some point in time. But that if I take the derivative of state, I get my events back out of the other side, right? So there's this kind of interesting idea here that if I structure my events the correct way, it gives me this like arrow of time state transition that I can go back, replay as long as I'm using the same logic to do that. And this is where like you start playing with these ideas of immutable events. You start playing with this idea that like it's almost like an accounting ledger where once these things have been declared, you don't change them. What you do is if you need to reinterpret or verify that some set of things happen, you have this log of all these changes. And so I don't know, it's one of those things where you obviously, and this is where the diagrams in the book, I will say, really help. So even if you're listening to audiobook, I would highly recommend going back and looking at some of this stuff. You need to kind of spend some time with these thoughts and think about it. Event sourcing is this like really powerful idea. Some people I think understandably have like criticism that this can get a little too pedantic and ivory tower. But there are times in which it's really, really important that you don't modify things. For instance, I think he talks about it here. One of my favorite non-blockchain uses of immutable logs, verifiably provable immutable logs, is the certificate transparency project. Are you familiar with this?
I'm not familiar with that, no.
So this is like my little soapbox pitch. After the Edward Snowden leaks happened, we realized that there are some trust model issues where some of the certificate authorities were actually issuing valid, quote unquote, certificates for state actors. And in this case, it looked like we were trying to catch bad actors in like Iran. And so like legitimate Facebook and other certificates were issued targeting folks in Iran where there was a man in the middle attack. And it literally gave you the green, the green padlock so that the browser, accepted it.
Interesting.
Yeah. So the tech companies come together and they're like, oh man, nobody asked us if they could do that. This isn't cool. And what if this happened through other state actors in other countries, right? And so they came up with this idea of the Certificate Transparency Project, which was this idea that every time I, as a legitimate issuer, issue a new certificate, I would write the pub key to the Certificate Transparency database. And it's an append-only log that actually, to this day, anyone can go, you can go download the entire Certificate Transparency Project's log and go audit it. It exists right now. And basically a bunch of the tech companies, Amazon does this, anything that you actually, if you issued a certificate off of the, for like your Elastic load balancer, you actually are participating in the Certificate Transparency Project.
Oh, interesting.
If you've used Let's Encrypt, you're using the Certificate Transparency Project. It's completely invisible to most people, but it's to identify, and it makes it way harder for a state actor to get away with this. Some browsers even verify the certificates versus certificate transparency. And so what's neat about this is that, yeah, you don't have to trust each other. All you're doing is attesting that this certificate was issued by this certificate authority on this date. And then you can go back and audit the append-only log and go, oh yeah, I didn't actually do that. Or, something's broken in the chain of trust. And so there's some really kind of cool public good stuff that comes from this that, and again, doesn't require, Bitcoin and proof of work and stuff.
Right. There was another concept I want to talk about. I don't remember exactly what it was called, but it's this idea that like, okay, so you have lots and lots of events coming in, right? Way too many events, but you might have some people that are interested in just a subsection of the events. I think the example he gave might have been like apartments going up for sale in New York City, right? Like on a Zillow type application. And so I've set my filters, and it's like, okay, I want to know which, if an apartment with 2 bedrooms that's over 1,000 square feet comes on sale, it's under this price, right? So basically, rather than doing like a query across all of those different events, and apartments is kind of like a funny example because like theoretically there's not that many apartments in the grand scheme of data, right? But when I was at a previous company, we were doing more like user analytics stuff, which had like tons and tons of data coming in. But rather than just trying to query that and being like, okay, like every 4 hours, I guess we'll just query all the data in the world and see what comes back. The idea is that as the events come in, they are run past the queries as they come in. And so an event will come in and it'll kind of, you might have all these different users who have set all their different kind of preferences. And then an event will come in and be like, okay, do I match this preference? Do I match this preference? Do I match this preference? And then if it does, it gets sent into a, or duplicated into that user's, I don't know, what's the proper term for that? But like that some sort of storage system. Like I keep using the term inbox, but I don't know if that's correct.
Some systems call it that, like mailbox or inbox. Yeah, mailbox. Exactly.
Yeah. But I thought that was really neat because I think when you think of like querying data, like everyone always thinks like the data arrives and then when I want to do something with it, I query it, right? And this is a pattern that had to be developed because like eventually you start working with quantities of data that are so large that you can't do this. And so it's one of those concepts that like when you hear it just makes so much sense. You're like, oh, of course, as data comes in, that's how you would handle it. But I think it's very unintuitive from how we typically think about data.
If you want to look at a really good open source implementation of this pattern, actually, if you look at ActivityPub, this is what it powers things like Mastodon and some of these other sort of alternative to the sort of decentralized social media. They have a really strong inbox pattern, right? Of like, how do you build a decentralized messaging system so that you can see who's, followed and done things. And it's a really powerful, I mean, it can be used for much more than social media, but it's a really kind of cool way of showing an implementation of something like this. But it's there's so much cool stuff. I will say that like 11 and 12 was a pretty casual read. I think it wasn't as many pages as we've had to read. Like some weeks was a lot. And so we actually got to spending a little extra time with streams was, I think, useful just because it's probably, you have to read the other chapters to get the most out of this chapter. But chapter 11 is probably the most important technical chapter in the book. I'll put it that way, right? Stream processing is probably the most valuable set of understandings that come into this. I would say up there with transactions. So like really should understand transactions. Transactions are really, really important, but also stream processing and the patterns around this is again, even though this is a 9-year-old book, people are still learning this stuff for the first time, this year.
Absolutely.
Yeah.
And I'm with you. It's when you think about like, okay, what technologies I'm going to run into my career? Like we had a whole section last week where we talked about like how time is an illusion and your clock is lying to you. And here's how to make sure the clocks all stay synchronized so that, you can agree on the source of truth for a particular transaction or whatever. And listen, you're probably never going to deal with that in your career. If you are dealing with that in your career, I hope you're being paid quite well. But transactions and stream processing, those are two concepts that are going to show up in your career. Transactions, certainly. But stream processing, just in general, there are a lot of companies. I'd be surprised. Any company of any sort of decent size probably has some form of stream processing going on.
Unquestionably.
In the company. Right.
Well, and the funny thing too is that actually, even when the MapReduce paper came out, right, that's the seminal work that really did all this batch processing MapReduce work. Google kind of like low key threw shade on it later and was like, oh yeah, we moved on that from that almost immediately to like these stream processing patterns.
Yeah.
And so I think the world's still been catching up. Google does this weird thing where they're like in an alternate universe slightly in the future, right?
Yeah.
Like they've just, they were using containers before it was Docker. They were using LXC. They were over provisioning, like a lot of these patterns that have become like kind of normal everyday things, or that lots of companies have kind of, a lot of them take for granted now. And we're seeing this, right? A lot of this is sort of like the afterburner, the afterglow of some juicy problem Facebook had to solve, or LinkedIn had to solve, or Google had to solve. And then they turn it into an open source project. A lot of times as a recruiting tool, I'll be honest, because they're like, oh, well, if we can get the community to learn how to use this pattern, and then we can hire them because we're maintaining some really juicy version of this. This is probably why Kubernetes was open sourced, right?
But I also know Google can be weird about that sometimes, where it's like they have like a lot of proprietary in-house technology, which you work on as a software engineer. And like that's any big tech company. Like I think like Facebook has its own like version control, right?
Yeah, they do. So Google does too. And then I knew a couple of folks who worked at Meta, / Facebook. And one of the crazy things, and again, I'm going to butcher this, but I know I've heard some stories about it. Apparently everything, and I'm not joking, like literally everything, infrastructure, systems and everything is like SQL queryable. Like they basically have this like master SQL query layer that can interact with anything in their system. And it was just like the weirdest custom implementation thing that like doesn't exist anywhere else. And Google's the same thing. Like I think they built Gmail before any of the modern JavaScript frameworks existed. And so they have all these like weird own version of like reactive type frameworks. So, back in the day when they called it Ajax, where they built these like JavaScript libraries that are literally only exist within Google, and do things slightly different than everybody else. And now it's this like thing that they have to maintain, right?
I also know like Google is also bad about like building on top of Google Cloud, like building their internal services with Google Cloud. I've heard they're getting better, but like, for example, Amazon is actually really good at that. Like even like a lot of AWS is built on top of AWS, right? And I mean, so much of Amazon.com is built on top of AWS, right? And so I don't have anything to say about that, but I think it's I think it speaks to the offerings of the two products. I've used Google Cloud, I've used AWS. I am an AWS guy. I'm actually quite a fan of the product for all of its warts and blemishes. But I think you can tell it's a little more battle tested than some of the Google Cloud stuff. Again, roast me in the comments if you like Google Cloud. I will say the Google Cloud project structure, the way they like manage projects, like is so much easier than AWS, like, and everything having a different account.
AWS has gotten a lot better with like multi-account org, but you can still tell it was kind of like tacked on later.
I know, right? Like,
but I became a big fan. I was an early adopter of the multi-account org structure. I've been using it in production for probably since 2020 or 2021. But for the longest time, they were playing catch up as far as the fact that Google, projects made it so much easier to kind of like what they call reducing the blast radius and doing these other things.
Right.
Oh, speaking of reducing blast radius, one of the last little kind of round out, I think that's we're kind of breezing over reasoning about time and maybe stream joins and some other kind of cool stuff. You should read it.
Time is an illusion. Just remember that. As long as you remember that.
One of the notable things, the last kind of section of this in chapter 11 was fault tolerance. And I hadn't really thought about what guarantees and stuff have to be in place. And he goes over, like the differences between things like Spark and Flink. And of course, these are the sort of main actors at the time. There's newer technologies that are out now, but so streams never finish, but interruptions can happen, and there's these trade-offs. You have to have things like exactly what semantics. You have to think about like, what is your batch size, latency versus overhead. You have to think about like, okay, so you have some failure state in your stream processor. what are you doing in the system to make sure that something that's failing actually gets processed and then the stream continues to move on? I thought this was like a really, again, a more interesting thought experiments of what do you do? What do you do when you have these failure states? I mean, and there's no correct answer. It's like he talks about the different strategies, but I just never sat and thought about what did it actually mean to kind of recover from these like that.
Yeah, I've been thinking about this a lot just because, like, where the system we have at work is running into some kind of fundamental limitations, and we're just at a crossroads. Like, we're a small company, you know, and so we've only got 10 engineers, and we're Series A and hoping to raise a Series B sometime in the, you know, near to mid future. And we're just looking at the kind of current system as it is, and it's a little like, you know what? If we wanted to, we could make this work. And there's a lot of kind of tuning around the edges that would get us a lot further than we are right now. But we're also looking at, it's one of those things like I kind of hate like, oh, we can't do X because it doesn't scale, right? And then like for so many companies, it's like, you don't actually ever need to scale. But we are looking at kind of our business model and what we want to be. And part of what we want to be is going to have to, like, if we want this company to be what we want it to be, then there's going to have to be some amount of scale involved. And so
Right.
you kind of have to look and say, okay, we're at the point where we could make some changes and introduce some new components. Like I've been talking about, like event-driven architecture. And we think that would be really, really beneficial here. And we think that we might be kind of getting ahead of ourselves in a good way, getting ahead of the problem. But we're also trying not to be like super starry-eyed about it. Like, oh, and then when we do this new system, there's going to be no problems, right? We're going to have fixed everything. Like, of course there's going to be problems. And so reading this kind of fault tolerance section, because yeah, and you move it towards streaming and event processing, like, yeah, there's a lot of new ways you can break the application, and those ways that you break it can be really hard, right, to fix in a way that's not just like, oh, just go in the database and rewrite the value if you have to, you know?
So, a couple of concepts here that I think, again, they're valuable whether you're doing stream processing or not. They're super valuable for REST. They're super valuable, honestly, for any distributed system. Idempotence, right? Idempotence is this idea that I can take some action, and if I take that action again, it gives me the same result. So it, you know, something that's inherently not idempotent is doing a, you know, n++ counter increase. So every time I hit an endpoint and it adds one to the counter, that's not an idempotent action, right? But an idempotent action would be, you know, I say, you know, update username, and it has this update username, you know, event. And then if I rerun that same thing again, it should give me the same output. I can rerun this thing 5 times, and it will just ensure that the name is updated to whatever the field is that I have in this idempotent event. One of the things that I hadn't thought about with this is like, you know, there's some systems that have, especially like Kafka, that have this concept of exactly once semantics. It was always interesting for me to think about what exactly once. I like that he in the book says that it's effectively once. It's actually like a better way of thinking about it, which is it's actually possible that an event gets processed multiple times, but the visible effect is once.
Oh yeah.
Right. And so the idea is that, hey, look, we guarantee that this thing will be processed, but that it actually requires that you either have an idempotent write or that you have a transactional output, meaning either one of these things I can guarantee that that this thing was only going to change the state of the system one time, right? You can think of it that way, which I thought was a much more useful, like, again, he's so good with like giving more. Exactly once kind of feels like a marketing term, where effectively once is like the much better framing for somebody who's building a system like this.
Right. No, that makes a lot of sense.
Yeah.
Well, I think we can talk now about the future.
Oh yeah, the future as it
transport ourselves back to 2016.
Yeah.
Think about the future. And granted, again, there's a lot here that still applies.
Yep.
Yeah, chapter 12 is really, really interesting. I mean, there's kind of like 2 sections to it, like where he talks about like, okay, here's what I think. Here's how I think data systems might evolve in the future. and this is where I wish I were more familiar with the current data systems landscape, because they'll kind of talk about like these neat ideas. I'm like, oh, that sounds neat. I wonder, does anyone do that now? Like that, this might be a solved problem at this point. And then there's also a kind of final section about like ethics and his concern about like a system or a world that is increasingly gravitating towards maintaining and collecting large amounts of data from its users, and like what our responsibilities are, um, and what the risks and dangers of this are. So I guess we can talk a bit about that first half. Like, okay, what does the future look like here, and what might data systems do? We can. I don't know, Nathan. Was there anything here that really stood out to you that you thought was neat, or anything that you listened to and recognized, like, oh, we're actually doing more of that these days?
Yeah. He kind of talks about like he one of the reasons that I was, we kind of spent a lot of time on the log based approach in chapter 11 is because he actually gives you a little glimpse of what cool things you could do with the log based approach in these distributed systems in the future, and sort of like the shortcomings that doing these data intensive things and understanding and reasoning about state and being able to do playback and proving that certain events happened in certain orders become a lot easier to reason about if you have these sort of like some of the event sourcing and event playback and immutable log sort of patterns. And he just gets to kind of explore these things. Like, one of the things that stuck out to me was I think it was called timeliness versus integrity section, where you basically say, timeliness is that users see up to date versions of state, versus integrity means guaranteeing that there's been no corruption to that, and that there is a trade-off here. And that, timeliness means that like if I timeliness with like an event-based system, it decouples these. And so like it's asynchronous, so it's not guaranteed that you're going to have the timely view on the data. But that if you use things like exactly once and idempotence, that you can guarantee the integrity, even though you may not have the timeliness. And so there's this, like, again, he kind of just explores like, what are these trade-offs, and like, what kind of systems would you want to build with these? And I don't know, I found it it was very like mature way of thinking about these kind of complex systems that we're building.
Right. I really like the section about where you talked about clients, stateful, offline, capable clients, and kind of talks about like when the web first came into being, right? Like all your client can really do is like request data and then display that data, right? And really the most interaction you can have with a web page is like scrolling it. He says he's talking about like single page applications and React, and saying like clients are getting thicker now. And so there's the possibility that you could have like a stateful offline capable client, where so you work offline using the local states, and then either via WebSockets or some sort of polling mechanism, like you're syncing so that you're pushing your version of the local state up and then also pulling the changes down, which is, I think we are seeing a lot of this. Like Notion is a really funny example, because Notion is like, oh, like it's a document editor, like that's neat. And like then for the longest time they did not have an offline mode, because Notion's whole thing is that like every document is a database, and like it actually is. Getting an offline mode was a really complicated challenge to solve, but when you first hear about it, you're like, what do you mean I can't edit my document without Wi-Fi? And so they're moving to something like this. But I also thought this was interesting because in some ways we actually are pivoting away from this, where like Next.js and server-side rendering has gotten hugely popular too, right? To make clients more performant, which is the idea of like, don't have these huge thick clients that we need to send down to the user, and then it makes it harder for like SEO indexing and optimization, right? Because they have a trouble exploring these single page applications. And so, I just thought that was interesting, where like we're seeing some of what he talked about here, but in some ways we are kind of going even further back to like make clients much less offline capable and much less stateful, and instead just pre-bake all this HTML for me and then send it down and make it quick.
I think a lot of this is like what is old becomes new again, sort of patterns. Right. again, we understand that there's these trade-offs, and depending on the shape of the work that you're doing, it makes sense to do it server side or it makes sense to do it client side. Tooting my own horn a little bit, we recently created a bookoverflow.io/episodes page, and one of the things that we actually have like a real Postgres database, and it has it has highly relational data like the episodes, the books that we've read, who the hosts and guests were, a bunch of stuff that I got to play around with. Thing is that
I just want everyone to know Nathan did this, and I modified the DNS record when he was like, "Hey, our website is cool now. It's not a React template you bought 3 years ago.
Yeah,
can you modify the DNS record?" I'm like, "Sure."
But I've been using a lot of Next.js, and it's been really kind of fun because like everything was sort of pre-rendered server side. It was really fast, but now I have a database that I'm querying. So I'm using like React Suspend, which does this thing where I can like have a placeholder and yank in data. But then I also like our data doesn't change that often, and so while I want this database to be the source of truth for our data, there's actually these other kind of cool caching layers where I'm using Suspend, but as long as the data has been rendered in the last 15 seconds, it's cached on the server. And I get to think through, honestly, all of these like designing, we're not data intensive. This is very small. But can I do a performant thing where like within 15 seconds, the data is updated on the website, but that for most people, it should be hitting the cache, right? Most of the time, our data doesn't change that much. But if I did change the data, would that update propagate pretty quickly? And it was actually using this book in my mind and thinking about which layer should handle which thing made it a lot of fun to work on, just thinking through these problems. And so even if you're doing little bitty things and you understand the technology that you're working on and you want to think about, who owns what and how does caching work and how do we do integrity and, what is the use case of the user at the end of the day? I like this pendulum swing that's happening, right? Because I started with, I didn't want to use a database. I just would do server side caching. I'd make it as plain vanilla as possible. And now I don't want to hammer our database with 100. We have 100 episodes now. Yay for us. But I don't want to have a query that returns 100 rows every time. So for instance, we paginate 15 rows at a time. But as you scroll down, it preempts that. And so there's like, I got to just like goof around and hack on stuff where I'm actually like preemptively loading the next 15 as we get close to your scroll being there, and just like magically shows up. So if you're actually scrolling, you get to see all 100 with no latency perceived. But in reality, if you're just like looking at the page and abandon it, we hit 15 rows of data, right? And so like thinking through these kind of problems and thinking about how I'm going to like query and serve and cache and do these other things is I don't know. This is like the joy of thinking about, building and presenting stuff like this.
Right. Is now the time we talk about ethics?
Yes. Speaking of, we got a really a sober thing to think about. Privacy and surveillance. I think that is, should we skip all the way there, or is it?
There's some interesting stuff. Like
actually, bias and discrimination is another one. I think, yeah.
Basically, that like, and I think it depends on how you view this, right? There is a thought process that like, look, it's a cold hard machine. It's just analyzing, like crime data, right? For example, like. And I know there's been discussions about this where it's like, it was controversial if Zillow was allowed to show you like if a neighborhood has more crime, because like just the way it works, at least in the United States of America, which is where Nathan and I are both from, neighborhoods with more, Black, brown, Hispanic people tend to have more crime. And so if Zillow shows you, hey, these neighborhoods have more crime, right, then that depresses home values in those neighborhoods, less people want to buy them. And then, and that obviously hurts people of those races who are, maybe trying to make some, obviously they want their home values to go up because that's a significant source of pretty much every American's wealth who owns a home. And there's an argument to be made that like, hey, we're just exposing the data. We're just telling you the true state of the world. But then there also is concern about bias, that it's affecting one group more than others.
Did you take AI ethics at Georgia Tech?
I did not. I think
Okay.
AI ethics. Wait, did
Well,
I?
it was
No, I took digital marketing.
okay.
There's kind of two classes going to be blow off classes, which
Yep.
it's okay. It's a hard program. There's only
I've
like two of them.
I took both. That's what kind of slacker I am. But so
You
I
got
will
to
tell
be
you.
graduate algorithms. You hang your hat on that, Nathan Toups.
No, so I will tell you though, AI ethics was one of those classes where I took it because it was supposedly an easy class, but actually ended up having like an amazing impact on me.
Interesting.
So it was one of those that shows us how much we can trick ourselves with data. And I think that's what kind of ties in. The importance here is that in the book, actually, and I think someone actually recommended one of the books for that class in our book discussion recommendations. Um, there is there's this whole idea of like garbage in, garbage out, right? If I'm collecting the data in some biased way and then I train a model in that biased collection method, I'm going to reinforce the bias on the outside, right? It's a very simple thing. And they one of the examples they gave was you wanted to understand the prevalence of high school students smoking cigarettes. And so you decide you're going to go to the parking lot at the high school and go around and survey and see how many people are smoking cigarettes. And you realize that the number is like pretty high. You look around and the people hanging out at the parking lot smoke cigarettes at a pretty high rate. But the thing is that that's not a representation, a proper representation of the behavior and activity of all high school students. You've picked a place that's like a hot spot for smoking cigarettes. And so therefore you're like, you could come to a conclusion if you didn't, scrutinize this and say, we have a cigarette smoking epidemic. Like the number of students that we sampled is super, super high. And again, for someone who doesn't understand sampling and doesn't understand how to collect data, they could take this and be very alarmed and run and do crazy stuff with it. I think that, exactly. For instance, not factoring in race and socioeconomic factors would actually skew that data tremendously because I'm from the South and there are affluent neighborhoods that have folks from, every different creed and race. But then there are also historically impoverished areas that are skewed one way or the other. And it's very complex, right? It really would be unfortunate to reduce something to some set of variables that are just misunderstood. And so, yeah, I think this is the reason we're bringing all this up is that he actually brings up the idea of bias and discrimination in a really clean way, which is that I think, was it machine learning is like money laundering for bias. I think that was like the quote from the book. And it is this, it's like, it feels very scientific. Like, oh, the data tells us this thing, right? And we've seen this, all of us have experienced this. As soon as somebody has a worldview that you vehemently disagree with, but are backing it up with some study, your spidey sense goes off and you're like, that can't be right. Like, I know that you said that there's this study that did this, and we've all found something that disagrees with our worldview. And of course, the tribalism of us is that we will reject that outright. We'll look for data that backs up my worldview. And then guess what? We're in a world with so many people in it. You can always find a study that's going to back up your worldview, like spoiler alert. And, and so you have to be really careful. Like my wife actually has a master's in analytics from Georgia Tech. And she actually she's substantially better at reading these papers and looking at the rigor that they've put into to measuring stuff that I'll miss all the time. Right. And she'll be like, oh, actually, the sample size is like super small. Or, oh, if you look at the standard deviation here, like it doesn't say anything. Like this could be a random roll of the dice, right? Or something. And I'm like, oh yeah, that's actually interesting. And I think a lot of stuff isn't scrutinized properly. Right. And so it starts with this thing of like, hey, you can be making an honest mistake and reinforcing biases that are really, really not helpful. But then it gets, I don't know, a step further, which is like, well, who's responsible or accountable for these outcomes? And I think we've seen this recently with AI tools, right? AI tools are these analysis machines on top of data sets. And we've seen this a lot. I mean, it's going to get controversial, but like ICE has had a really bad track record with misidentifying people and yanking them off the streets because their name matched up or like a profile mismatched or they accidentally applied records. I think I heard a story recently where like there was a guy who was an actual US citizen, but an immigrant who was like yanked off of a cruise ship because he was misidentified as some drug dealer. It was horrible. Like this guy was actually like a military vet and a bunch of like literally the worst PR nightmare, but also like a hellish nightmare for this guy who's done nothing wrong. And you look at these kind of things and you're like, okay, this is a high profile cut and dry case. How many folks maybe had like a few misdemeanors but weren't actually felons, but because they got yanked up with their misdemeanors, they actually got, all these other things going on. And it gets really fuzzy where you go, we have a group of people acting with authority on data that obviously is flawed. Like there's a few examples of it, and maybe most of the time it's right, but it's wrong enough that it's horrible, right? Absolutely horrible.
Yeah, well, and because I was thinking too about some of the what I will politely characterize as overreaches of our federal government recently, and he talks about like basically like the great kind of like bargain we have made in the 21st century is free services in exchange for our information, right?
Yeah.
And I, on the whole, with the current system, think that this has been a good trade. The world as it stands today, I think we have gotten a lot of great services in exchange for what I consider to be something pretty, like I don't care if someone knows my search history, but that's today with the current actors of today. As I don't think we live in some sort of dystopian hellscape, right? But he points out that like we have all willingly opted into like carrying a tracking device with us everywhere we go. He says you go back to like the 70s, the 60s, not even the most dystopian novels envisioned a future like that, right, where all citizens could be, tracked very easily. And it's a little like the tools we've created. And even though I think in the aggregate, we are wielding these tools today somewhat responsibly. Again, we have not turned into a totalitarian state, right? There's a lot of power out there. And he has this interesting he compares it to the Industrial Revolution, where he says, like, the Industrial Revolution, we invent all this new technology. And in a lot of ways, it's really great for humanity, right? And lifts a lot of people out of poverty and really moves us forward as a race. And pollution is just not even on the radar. Like, no one's even thinking about that this could possibly be a concern. And then, surprise, it turns out it's not great to just pump tons and tons of greenhouse gases into the air constantly, right? And so we've learned about that, and now we kind of look back on our ancestors and go like, oh my gosh, like how could you even do that, right? But we are now working to remedy the mistakes of the past and move towards cleaner energy sources, right? He thinks that we are kind of in the Industrial Revolution of like data right now, and that we have little concern for all the ways we're abusing the data and all of the potentially powerful tools we've created, and that future generations will look back on us and be like, oh my gosh, like they were just handing their data out willy-nilly. This is related, but not the exact same thing. But I kind of think that way with like, we are obviously living through kind of a period of great social upheaval in response to social media. And I've talked with friends like, is it kind of all are we always going to constantly be in an environment like this? And I remain somewhat optimistic in the sense that I'm like, I don't think there's going to be a revolution bigger in the world history than inventing the internet and putting it in everyone's pocket, right? Like that is a huge fundamental change from how the world operated in like 1989, right? And so I think we're learning how to deal with that, and I'm optimistic we will continue to learn how to deal with that and come up with better patterns for us. But it's tough because you're also working in, like, I hope one day we'll all kind of regulate our screen time better and do less doom scrolling and come to a healthier place as a society. But the social media companies have every incentive for that to not happen, right?
Right.
I don't know. It's a lot, but I think I thought that was an interesting parallel that basically like we are living through another industrial revolution and just barely starting to grapple with some of the pollutants we're putting into the air. And hopefully, like the previous industrial revolution, we will learn how to deal with that.
Yeah, no, and it does. It leaves in this like sober note and kind of puts a challenge to you to say, we should try to make our not just our children proud, but like our grandchildren proud? Are we building a world in which people can opt out and people can actually understand what's going to be done with your data? And we're always seeing this, right? Like, I think it's even much worse than it was when it's how much of our digital exhaust or this stuff has been used to like manipulate people's behaviors and their sentiments about things. I think, a big part of the argument of who controls TikTok is based on like
Right.
who gets to censor which data and why. And that should be concerning to anyone because, again, it's not that in good times that we have these powers. It's in bad times, the people who might abuse them are the ones that we should worry about. And are we centralizing control in a way that if the wrong people, and wrong people defined by you, right? Because we are a democracy, the wrong people defined by you.
The Polish.
Oh boy. Yeah.
they get a hold of this. We're done.
Yeah. So that's the thing is like it's defined by you is that, I like to do this a lot with like playing Mad Libs, right? Play Mad Libs takes any topic in the news, switch the political parties, switch the leaders.
Right.
Or would you still agree? Would you think that this was overreach, or would you think that this was a good use or bad use of power, was in the interest of the public or not interest of the public? And if the power itself makes you uncomfortable when wielded by the party or the people that you don't like, it's probably power that the people you do like shouldn't have either, right?
Right.
And so it is. It's really. I really appreciated the book kind of rounds out on this because we just spent all this time, the first 11 chapters, figuring out how to get more power and energy and extraction out of data at scale. And then he's like, by the way, we could do some really awful things with this if we're not careful.
Wow, it was fun. It was fun, I guess not the potential that we'll do really awful things. That's not fun. But we did it. We read Designing Data Intensive Applications. And if you are listening to this podcast, you have listened, hopefully, to all 4 episodes of Designing Data Intensive Applications. So, pat yourself on the back too. I guess we can talk a bit about some of our hot takes. I think I kind of shared all of mine over the course of like I guess I do have one hot take, which is that with this, I think most of our hot takes will be associated around this ethics section, right? Which is that like, I think you should strive to make the world the place you want to live in. And I have little patience for people who like work at Google and then profess to like hate Google. You actually have a lot of control over how you spend your time, right? And I just think like if you think that like manufacturing weapons is bad, don't work at Lockheed Martin, right? And like I've just seen too many people do that and be like, well, I need a job, don't I? I'm like, there are so many jobs out there, right? Like I have had people reach out to me, I'm religious myself, and I actually had MindGeek reach out to me, which is like they do like Pornhub. They have like a bunch of pornography companies, and I myself am not, a fan of pornography, right? I have some moral opposition to it, and I just think like I am sure that the engineers at these companies, for the most part, are doing very boring engineering tasks every single day, right? And you can probably go there and just work on those kinds of engineering tasks, and for the most part, it's fairly separated from the actual product you're pushing. Most of our jobs are like that, right? I still would not work at those companies because I think that is furthering a mission that I don't believe in, right? And so I see too much of this online with people who claim to like hate some larger value, right? Like, oh, I can't stand the internet surveillance state. And then you look at it, like they work for Facebook. I'm like, what are you talking about? There are so many companies you can work at. Don't be part of something that you think is evil. And you have more agency than you think you have in this situation. So I don't know. If you're like that, cut it out. And apply your talents and your vigor to what you think will make the world a better place, or at the very least will not make the world a worse place. So I don't know. That's my take on that.
No, I like that. I'm in a similar boat in that I think that the ethics section of this book should be required reading. I actually think that most computer science programs these days should actually have ethics as part of the official curriculum, just because we don't have a licensing board right now. And I think that there's
Right,
probably a
right.
good reason for that. But there are types of software engineering in which I kind of wish we did sometimes, in that I wish that there was some sort of binding code of ethics in the same way that we don't want attorneys or doctors to misbehave in a way that was defined by their industry. I would love for this to be like defined by, software industry itself. Um, but I do think that there are some people in certain hot code paths using some certain technologies that it would be nice if they had some sort of binding code of ethics that we could go, oh wow, you know what?
Right.
They're doing this, but they're also bound by that code of ethics, and we know that they're at least not trying to cause harm in X, Y, and Z, right?
I wonder if the rise of large language models makes the idea of a software engineering licensing board more or less likely. Because on one hand, you can kind of see like, yeah, it's
Right.
the democratization of code. Anyone can produce code. On the other hand, I could see there being a lot of value in someone having a credential that says like, I know what I'm doing. And, even though the future is here and we
Right.
are just at an age where large language models will probably generate most of the code written from now until the end of time. I think the era of like humans just churning out lots of code is over. But I wonder if there would be value in like basically saying like, I understand the code that this is outputting. I don't know. It's just interesting because like you see that in like a lot of open source projects are saying like we are not going to let people open PRs anymore because you can just churn out so much code with large language models that we're getting all these garbage PRs. In the past, like the natural gatekeeping for these open source projects was, did you take the time to write the code for the PR? And if you did, that's probably a sign you invested some sort of,
Yeah.
enough time into this.
I
And we're just moving away from like that qualification of like, can you produce code doesn't signal nearly as much as it used to. So maybe we'll have to move on to other signals. What those
yeah.
are, I have no idea.
I will say I am a large language model user,
Oh
specifically
yeah.
for certain types of projects, more heavily than others. I will say I love a good critique, and I've been paying attention to Kelsey Hightower, who I have a ton of respect for, has been giving these like really great contrarian hot takes on why he likes to write code by hand for certain problems he's solving, and very principled approach. And again, I always appreciate a principled approach. Another person that I think is a shining beacon in this area with contrarian hot takes is Cory Doctorow. He is very anti sort of foundation model consumer, stuff. He has some really good critiques on like why the business model just doesn't make sense and as a reason to give you pause. And of course, he's involved with the EFF. And whether you take everything he says face value or not, or you think that maybe his outlooks are not exactly in alignment with yours, it these are deep thinkers and they're really respected folks in our industry. And I highly recommend at least listening to their perspectives because you're going to have a richer understanding of your worldview if you listen to folks who have critique amongst the echo chamber of the, all of our jobs are going away. Large language models are the best thing ever audience as well.
Right. Yeah. It's, I'm inclined to believe that all the work we're doing here on Book Overflow, and if you're listening to Book Overflow, that there's still value in understanding systems deeply, and that the job of software engineer is not going away, right? And I know I'm wrestling with problems at work. I was wrestling with a problem for weeks, and I'm like, I wish large language models could just solve this for me because I'm going crazy trying to solve this. But it's a turbulent time in the industry. Obviously, there's lots of change right now, but the cream always rises to the top. And I think if you put in the work and you work hard and try your best to master this craft, like it's not going to go poorly for you. So a little note of encouragement here at the end of this seminal book. I guess we can say what we're going to do differently in our career, having read this book.
Yeah.
What do you got, Nathan?
I've used most of the Kafka that I've run into have been like mature deployments of Kafka where we're interacting with it. I've actually never set Kafka up from scratch or even used some of the like useful flow. And I want to spend some time with it and play with the patterns and tools and follow some blog posts. So I'm carving out some time to deal with setting this up from scratch and maybe doing like Kafka the hard way or something.
Nice. Yeah, I just want to implement anything event driven. I'm with you. I've worked in event driven architecture in the past, but never built it. This is kind of cheating because we're already planning on doing this at work, but I have, again, that whole fault tolerance section really made me think about like, okay, how do we make sure that we do this in a sustainable way? As far as book recommendations, I'll go this one, or same as last week, Sickos and Maniacs. If you are just absolutely chomping at the bit to learn more about this after having listened to this episode, like do it, because this is a fantastic book. But I think for most software engineers, if you're just like, hey, what's going to level me up in my career the fastest? Like I said it before, but like read Fundamentals of Software Architecture, read A Philosophy of Software Design. Honestly, read Made to Stick for communication. If you're a manager, read Radical Candor, the DevOps Handbook. Like these are all the things that jump out to me as like, this is what I think would take like a junior to a mid-level or a mid-level to a senior the fastest. Designing Intensive Applications, probably I'd say the most textbook-like book we've ever read. So make of that what you will, but all books have their purpose, and this book accomplishes its purpose perhaps better than any book we've read on the podcast. Nathan, what do you got?
Yeah, I'm going full circle, right? Each week I'd been progressively being like, wow, you have to really be committed, all these other things. I'm going full circle all the way back to my first week's recommendation, which is this is a great book for software engineers who are deeply curious about systems architecture, who want to grow in their understanding of trade-offs. And I said, as of part one, this is not a tutorial on how to build stuff. That is as of all three parts. This is not a tutorial on how to build stuff. It's a way to think deeply about distributed systems and how data flows. If your job has taken you into this subdomain of work, right? And again, I would say that there's entire fruitful career paths in software engineering that doesn't make this your daily driver. But if you are interested in getting into software architecture or systems architecture, or you're maybe DevOps and you want to get into platform engineering, and you want to really kind of understand how data flows work, data engineering, ML pipelines, these kind of things, I would say that this book is absolutely essential. That yes, all the books that Carter recommended need to be there as a foundation, but at some point you're going to want to, if you're in a position where you're like tuning the machinery of how data flows through there, this is a book where I regret that I didn't read it earlier in my career. I wish this was a reread for Book Overflow, and it wasn't. Yeah,
I think we hope to reread this at some point with the second edition coming out. I'd love to do a more targeted reread, and like especially if it's just like chapters 5, 7, and 11 are radically different, and then we could just reread those. But we'll see.
If we're lucky, supposedly the second edition comes out in March. It's been pushed off a couple of times. I will say, I don't want to commit to it yet, but I think it would make sense for us to reroute our schedule a little bit, just because it'd be timely and people are going to be curious since the new book comes out. So if you'd like us to prioritize covering the differences, we won't do a full reread. It's just way too many. We're not doing 8 episodes in 2026. But if we can get a good breakdown of the diff, we'll read the diffs, and then we'll do like a second edition update episode or a couple episodes maybe. That sounds interesting to me. I'd want to know. So
there we go. Well, and we have earned a much needed break, and so we're not going to take a break from producing an episode next week, but we are going to read an essay. That is in part because we are doing because we read Design That Intensive Applications, and it's a huge book, but also because I'm actually going out of town next week. You're listening to this on Monday, and so Tuesday we are flying to Disneyland. I'm taking the kids to Disneyland, my wife and I, so that's going to be a lot of fun. But they don't know about it yet. So if you're listening to this, there's going to be about a 36-hour window where the Morgans are going to Disneyland, but my kids don't. So hey, relish that knowledge, folks. Yeah. Anyhow, but, what are we reading? On Trusting Trust. Oh, sorry. You
exactly. Yeah, we're going to be reading Reflections on Trusting Trust, which is a famous Ken Thompson paper and talk that he gave when he accepted a Turing Award. I think it was a Turing Award. And was it? Yes, it was a Turing Award lecture, which, seminal work. And then Coding Machines from Lawrence Castelloot. And this was actually recommended. So again, big shout out to the Discord. We have a section on our Discord. It's called Book Suggestions. You can suggest books that maybe we haven't covered, but you would love for us to make a case for why you do it. Everybody on the Discord can comment and talk about whether they also would like to hear that or not. This was a suggestion from somebody who's like, hey, I know that sometimes you do essays and blog posts. If you ever need a breather, this would be a really good one to put together. And we took that suggestion. They have influenced the future of Book Overflow. If you want to be a part of that, come join our Discord. You can go to bookoverflow.io, and there's a link to our Discord at the very, very top of the page.
There we go. All right. Well, so we're reading, is it 2 essays we're reading then?
Yeah. So it's, 2 essays. They're pretty short.
Right.
Coding Machines is like 30 pages, and then Reflections on Trusting Trust is 3 pages. So
there we go. Yeah. All right. Well, it'll be fun. Thanks for listening, everyone. Again, go to bookoverflow.io to see our new snazzy website. And you can contact us at contact@bookoverflow.io. We're on Twitter at bookoverflowpod. I'm on Twitter at Carter Morgan. Nathan has worked with his consulting agency, and his newsletter is rohorobato.com/newsletter. Thanks so much for tuning in, everyone. Thanks for sticking with us for all the design data intensive applications. And we're excited to move on to something new next week. So we'll see you around.
See ya.